All right. So if I asked you, how would you define a parabola? You might give me lots of answers like it's U-shaped, it has symmetry, has an axis of symmetry, it has a vertex, it can open up, it can open down. You would be telling me all sorts of things like that. But what you would really be describing are some of the parameters of a parabola. You wouldn't really be telling me what the definition of a parabola is. How is a parabola made? And so that's what we're going to be talking about today. So if you looked up the actual definition of a parabola, you'll see something that looks like the curve formed by the set of all points in a plane that are all equally distant from both a given line called the directrix and a given point called the focus that is not on the line. So that's a lot to kind of take in and to try and figure out. So what we're going to do today is we're going to do a paper folding exercise to show you how a parabola is actually formed using this thing called the directrix and the focus. So let me go here. So this here is actually in Google Classroom. It's called, I don't know, paper folding, focus and directrix. If you'd like to try it yourself, you certainly can. Um, you can use regular paper. However, I have wax paper. You can kind of see here. It's hard to see on here, but just wax paper. And the reason I like to use wax paper is you can see through it, so it makes the exercise a little bit easier. So the first thing the exercise asks you to do is to take your paper and hold it horizontally like this, or vertically, I'm sorry, vertically like this, sort of like, an 8.5 piece of paper that would look like this. And you're going to draw a line about a third of the way down your paper. It doesn't have to be exact, just approximately. And you're going to call that line your directrix. Then you're going to put a point A about in the middle of your paper. Again, it can just be estimated. It doesn't really matter. And that point is going to be called the focus. And then you're going to start folding your paper. You're going to take this end of your directrix and you're going to fold it up to the point of your focus and make a crease. So I'm going to take this end, I'm going to, just so they touch, I'm going to make a nice crease right here in my wax paper. Now I'm going to take this and move it up a little further so that this point is going to kind of continually go down this line here. So I'm just going to pick it up and I'm going to kind of take small steps. I'm not going to take too big steps. And I'm going to just fold the paper again. And I'm going to keep moving this down. So I'm going to move this down again a little bit. And I'm going to fold the paper again. I'm going to move it down a little bit more and fold the paper again. And you're going to keep doing this until this line is almost horizontal. I'm going to start taking some bigger steps just to quicken this up, but you should continue at small steps so you get a nice curve at the very end. So I'm going to keep going like this, keep going like this. I want to make sure you can see it. Keep going like this. Just keep going down that line until you can see that it's pretty much horizontal. And so now I have this paper and it's got a bunch of creases going this way. I'm now going to start on the other end and do the same thing. So I'm going to take this end and put it up at this focus and I'm going to make a crease. Oops, kind of messed that crease up. Then I'm going to pick it up and kind of move it up a little bit again and make another crease. And I'm going to keep doing that until this side is almost horizontal. And you're going to see what happens if you made your folds small enough. You can see, if you can kind of see here, I'll get my pen, you can see here that what you have created right here is, from the outside of your fold, is a parabola. So that is how you would define a parabola. That is how a parabola is actually created. I want to jump back here and just kind of go through some of the questions on this worksheet. It says, on the paper, sketching the curve formed by the creases, what shape does it look like? Obviously, it looks like a letter U because it's a parabola. Then it says, fold your paper so that the line lies directly on top of itself, forming a crease through point A. So we're going to just kind of fold this in half through point A so that the directrix here is on top of itself, and the parabola is kind of on top of itself. And give that a nice crease. So what would you call that line? Well, this line cuts my parabola completely in half. So this here would be my axis of symmetry. And then it says, draw and label point B at the intersection of the dashed line and the curve. So I'm going to call this point B. And draw and label point C at the intersection of the dashed line and the original line which is the directrix. So C. And then it says, fold the paper horizontally, matching point C over point A. So if I take point C and match it up to point A, what happens? Well, it folds right in half at point B. So now it says measure the distance between AB and BC. Well, if I take my ruler, see if I can take one that you can read, and if I measure AB, hopefully you can see this, that's about 4 centimeters. And if I measure BC, that's also about 4 centimeters. So this tells you that this distance equals this distance, and this distance is actually called distance P. That's P. Okay? And so you can conclude that the focus and the directrix are always going to be equidistant from the vertex. Now, the focus will always be on the inside of your parabola, and the directrix will always be outside of your parabola. And then the rest of the sheet goes through and asks you actually to derive the formula, which you don't have to do. It's not really that important. You could try it if you'd like, but some of the algebra gets a little bit tricky. But the other thing that you want to see is that it says to put a point D anywhere on your curve. It doesn't really matter. And then you're going to draw a segment from A to D, and then perpendicular from D to your directrix. And then you're going to measure that distance. So again, if I measure this distance here, you can see this is about, maybe 8.5 centimeters. And if you look here, again, it's 8.5 centimeters. And it's pretty close considering how rudimentary this is done. That's measuring pretty close to 8.5 centimeters. And that'll work no matter where you put the dot on your parabola. If I draw a line from any point on my parabola to the focus and then draw a perpendicular line down to the directrix, those two segments will always be congruent, or the same measure. So this is going to be the same length as this. And that is your definition of a parabola. And from that, what you really get, if you did go ahead and finish this worksheet and derive the formula, you end up with the equation y equals 1 over 4p x squared, which you can see is very similar to the equation ax squared. You know that the vertex here would be at 0, 0 in both these places, right? And so you can see that this a value is also equal to 1 over 4p. So you could use that in order to determine your a value. If you had a parabola that was, 1 over 8x squared, and you wanted to know what p is so you could find your focus and directrix, you could say, well, I know 1/8 has to equal 1 over 4p. So I know 8 has to equal 4p. If I divide through by 4, I know p has to equal 2. So that way I know if I were to draw this parabola, I know it goes through 0, 0. I don't know exactly what the shape would look like, but it doesn't really matter for this. So here's the parabola. I know that p equals 2. So I know my focus has to be on the inside of the parabola. So I know it's going to be 2 units up from the vertex. So my focus would be there. And I know that the directrix has to be equidistant, so it's going to be 2 units below. So then here my directrix would here be at y equals -2. And there you have it. If you have any questions, let me know.